So today we're looking at more quadratic functions, and we're looking at how do we convert vertex form to standard form. And it's actually pretty easy as long as we remember our order of operations. So vertex form looks like y equals a times x minus h squared plus k. And remember that the helpful feature in vertex form is the vertex. Makes a little bit of sense. We get that right from the h and the k values. Standard form looks like y equals ax squared plus bx plus c, and our helpful little value is that c value, which gives us the y-intercept for free. Now, what you should also notice is that both of these forms have an a value in them. It's actually the same exact number, the same a value. So that's one way that we can check our work as we go through this process. Another way that we're going to see to check our work is to use Desmos to make a graph. So if we're converting from vertex form to standard form, we're going to use the order of operations to multiply, simplify, and rewrite the the vertex form expression. So the order of operations, I know we know it, but the vertex form, just the nature of how it's written, tends to trip people up a little bit. So I want to make sure that we review that in a way that's going to be helpful for us. So you've probably heard the abbreviation PEMDAS before for order of operations. So you know that the P represents the parentheses. We want to simplify anything inside parentheses first. The E is our exponents. We want to apply exponents before we do any multiplication or division. And in this process, we're not going to do any division. So I might just cross that out so that we don't have to worry about it. And then the absolute last thing we do is any addition or subtraction, right? And addition and subtraction come at the same level. We just go left to right. So vertex form, every vertex form expression has parentheses in it, but if you look at what's inside the parentheses, there's actually nothing to simplify. So example 1 says y equals x plus 4 squared minus 9. X plus 4 can't be simplified. There's no like terms there, and it's going to be the same with any other vertex form equation that we do. So I don't really have to worry about parentheses. I can go straight to my exponents. Now, what does this mean, x plus 4 squared, right? We have a square there. What it does not mean, it does not mean we get to distribute a square to everything inside the parentheses. That is not what we're doing. We are multiplying that quantity, x plus 4, by itself. So when we say squared, right, x plus 4 squared, we're really saying that that is x plus 4 times x plus 4. And we're going to see that that's not equal to x squared plus 4 squared. This minus 9 just kind of follows along for the ride, and that's okay. It is subtraction. We're going to deal with it at the very end. So now that we've got this expanded, we're going to use our multiplication. We're going to multiply x plus 4 times x plus 4. Whether you prefer the box method or double distribution, it doesn't matter. You can do either way that you like. Just remember that every piece gets multiplied to every other piece, no matter how you do it. So you'll end up with x squared plus 4x plus 4x minus, oops, excuse me, got a little ahead of myself. 4 times 4 is positive 16. And then that minus 9 again is just hanging out at the end. So we have nothing left to multiply. We've applied our exponent. We've used multiplication. All that's left is addition or subtraction to rewrite or simplify this expression. So there are some like terms that we can simplify. There's 4x and 4x, and there's 16 minus 9. So we're going to get x squared plus 8x plus 7. 16 minus 9 is 7. So apparently this is my standard form of the vertex form expression that I started with, x plus 4 squared minus 9. So again, I just want to show you really quickly, we can use a Desmos graph to help us confirm that. So if I take a look at my graph here, I've got x plus 4 squared, whoops, minus 9 in red, and then I've got my x squared plus 8x plus 7. And when I graph this, it should be exactly the same as my vertex form. So they are in exactly the same position. They just lay one right on top of the other, which means that they are equivalent, which means we've rewritten this correctly. So again, remember what that squaring means and what it doesn't mean. So we're going to do example 2 together again. Example 2 has an a value of 3. So let's think about what that a value of 3 is. It is being multiplied by x minus 5 squared. And remember, multiplication comes after we apply the exponents. So that 3 is actually just going to hang out for a few minutes. I'm just going to leave it out in the front while I deal with this x minus 5 squared. And again, just like the last example, this means x minus 5 times x minus 5. That plus 2 hangs out at the end. So I'm going to keep highlighting this center expression here to show you just where everything is happening. I'll highlight the 3 and that plus 2 again so that you can see where all of these pieces are going to be along the way. So I square. Now I need to multiply, and I'm going to multiply x minus 5 times x minus 5. That 3 is just going to wait a minute. I can use the box method if I like. If I prefer double distribution, again, it doesn't matter. It's our own choice. However we want to multiply it, as long as we, multiply correctly. So that 3 is still hanging out, and what it is multiplied by is an expression that's the same as x minus 5 times x minus 5, which is x squared minus 5x minus 5x plus 25. And then that plus 2 is still chilling at the end. So that plus 2 is still there. That 3 is still there. And we're just kind of working with this center expression first. Now, one more thing I'd like to do before we multiply that 3 is I would just like to simplify. We can think of this as the parentheses step. What's inside the parentheses, I have to simplify before I can multiply that 3. So there are some like terms in there, negative 5x and negative 5x combine. So we'll have x squared minus 10x plus 25 inside those parentheses. And now I'm just about ready to multiply through by that 3. Let me just get highlighting all taken care of here. So now that those parentheses are completely simplified, there's no more exponents to apply. Now I can distribute that 3 to everything inside. So I'm going to get y equals 3x squared. 3 times negative 10x is negative 30x, and 3 times 25 is 75. And then that plus 2 at the end. So that's the last thing that we haven't really used at all, right? Addition and subtraction come at the end of our order of operations there. So now we can combine it with the 75 with our like terms there. So we're going to get y equals 3x squared minus 30x plus 72. 77, not 72, 77. Now again, I can always check this by making a graph on Desmos. Something else I can look for is the a value, right? We mentioned that both vertex form and standard form have the same a value, which is consistent with what we have here. We started with an a value of 3, and we ended with an a value of 3, and that's exactly what we want to see. So a couple of different things to look out for while we're doing this. So I'm going to have you do the next these next 2 examples, try them out on your own, and we will check our answers, and you can always check the process as well and ask any questions at the end if you need them.